today we're going to talk about rational numbers. Okay, here I've listed out natural numbers. It's just numbers 1, 2, 3, 4. It's numbers you learn when you're a little kid. Then you learned whole numbers, which it's natural numbers with 0. Then we've talked about integers. We just talked about them like last week. Integers are whole numbers, 0, 1, 2, 3, and so on. And it's the negative numbers. So -1, -2, -3, -10, -50. The one thing you need to know about these 3 sets of numbers are you don't see decimals and you don't see fractions. All you see are whole numbers like 1 and 2 and 3 and negative numbers. They don't have decimals and they don't have fractions. Alright, you need to write this down. Now you have rational numbers. It's any number that can be written as a fraction. So whole numbers and natural numbers, they didn't have decimals, they didn't have fractions. Now we're talking about numbers that do. A set that has pretty much everything else. It's any number that can be written as a fraction. I can write 0.87 as a fraction. We're going to do that here in a minute. I can change a decimal. This is what we call a terminating decimal. You sure learned it on Moby Max yesterday. This is a terminating decimal because it ends. I can write that as a fraction. 4/5 is already a fraction. -2.56 repeating. I'm going to show you how to change a repeating number into a fraction. So this can be written as a fraction. -23 can be written as a fraction. So they all are considered rational numbers. Alright, write this down. This is what a lot of your homework is going to say. It's going to say write each rational number as a fraction. -15, I can write that as a fraction just by writing it over 1. If it's a whole number or an integer or a natural number, you just write it over 1, it becomes a fraction. If they give you something like this, even though it's a fraction, what they want is an improper fraction. I change a mixed number, a whole number with a fraction, by timesing by the denominator and adding the numerator. So 6 times 6 is 36. I add 1, I get 37 over 6. The denominator doesn't change. We have a negative mixed number. Okay, and please pay attention to this. I had some questions last hour. You have -4 2/3. What I do is I know this is going to be a negative fraction, so I leave it as a negative, and then I don't bother with it. Okay, I forget about it. Because what people want to do is they want to do -4 times 3 and get 12, and then add that to 2, which you'd actually get -10. And is that right? No. So what I do is I carry that over, and then I do 4 times 3 plus 2. I treat them all like they're positive. So 4 times 3 is 12. 12 plus 2 is 14. So that gives me -14 over 3. Do not do -12 plus 2 and give me -10 over 3. Is that the same thing as -14 over 3? No. So we just forget about 4 being negative. Okay? We just make our fraction negative and then we don't worry about it. Any questions there? Alright, write this down. Alright. Another part where your homework is going to say write the decimal as a fraction in its simplest form. So you write it as a fraction, then reduce. Here's how you do that. You take what's behind the decimal and you write it as the numerator. So 6.64 would be written over a number. The only thing you got to figure out is what is my bottom number? What's my denominator? Well, here's how you do that. What place is that 6 in? Do we remember what decimal place it is? That's the 10th decimal place. What about the 4? What decimal place is it? It's in the hundredths decimal place. So what do you think you should write 64 over? 100. It's 64 hundredths is how you read the decimal, and that's how you read the fraction. 64 over 100. Can I reduce that? Yes, I can take 2 out of it. Gets 32 over 50. I can divide again by 2 and get 16 over 25, which doesn't reduce. Any questions how to do that? Now you have 9.675. That's just going to be written as a mixed number. What's in front of the decimal What's to the left of the decimal is the mixed number. It's the whole number. And then you write 675 over a number. What would that number be? Someone raise their hand. Ben? 1,000. Because the 5 is in the thousandths decimal place, you write it over 1,000. If you're not for sure, count it. 10, 100, 1,000 decimal place. So I write over 1,000. Which I can reduce. I take 25 out of it. I believe I get 27 over 40. So 9 and 27 over 40 is my answer. Now, like I told you, you can write repeating decimals as fractions, and that's what you have right here. 0.6 repeating. This is what it looks like if I was to try and write out 0.66666. Hey, if you did it in a calculator, it would round and write 7 right there. Okay? But that's what a 0.6 repeating looks like. Here's how I write it as a fraction. Now, I can do one of two ways. I can do like I did the first year I taught this, and I followed the book's example and showed you exactly how each step to do. So it kind of makes sense. Or I can show you the shortcut. Right? And here's why I just want to show you a shortcut. If I showed you the other way, it probably wouldn't make sense to you, and you're going to get the exact same thing as if you just skip to the shortcut. So I'm going to teach you the shortcut. 0.6 repeating. I'm going to take what's behind the decimal, write it as a fraction, 6 over. Now I can't write it as 6 over 10 like we've been doing because that would give me 0.6. Is that the same thing as 0.6 repeating? No, 0.6 is not the same thing as 0.6 repeating. So I don't write it over 10. Instead, I write it one less than that. I write it over 9. And if you want to see if that works, put it in a calculator. Do 6 divided by 9. Guess what? You'll get 0.6 repeating. Alright? That's just how it works. Hey, if you want something to repeat, you write it over 9. That's the easiest way of doing it. I can show you how it works. Okay? But for the most part, just trust me. Alright? It's going to save you a lot less time, and you won't be as confused because this is pretty simple, right? Okay? You write it over 9, it makes it repeat. Now, can I reduce 6 over 9? Yeah, 2/3. Which, guess what? If you take 2 divided by 3 in a calculator, guess what you'll get?
6 repeating.
0.6 repeating. The exact same thing. 0.42. So I take what's behind the decimal, I write it as a fraction. Can anyone take a guess and guess what my denominator is?
99.
99. What I do is I count how many decimal places there is. There's 2 decimal places, so guess how many 9s there is? 9. Or there's 2 of them, right? 2 9s. Okay? Okay? I count the decimal places. There's 1, 2, so how many 9s do I need? 2. Easy enough. Hey, if I put 42 over 99 in a calculator, I'm going to get 0.42, 0.42, or 0.42, 42, 42, 42, right? Okay? This is the easiest way, just knowing it's over 9 or over 99. That's as simple as it gets. Alright, you don't have to write the words or the phrase, you just have to write the decimal. So write 0.6215 repeating. 0.36215 repeating, again, I just write what I see on top. Someone tell me what they think goes on bottom. What is it, Ms. Beck?
99,999.
There you go. Okay, count the decimal places. There's 5. 1, 2, 3, 4, 5. So that's how many 9s I need. So 99,999. The phrase underneath just tells you any repeating decimal can be written as a fraction. So repeating decimals are considered irrational numbers. You can write repeating decimals as a fraction, so it is considered rational. Now I do want you to write this down. Decimals that neither terminate nor repeat are called irrational numbers. So decimals that don't end, but they also don't have a clear pattern that you can do mathematically like on a calculator, are called irrational numbers. So irrational don't make sense. They don't apply with the rest of the rules where everything else can be written as a fraction. Since you can't write them as a fraction, they're considered irrational. 8.78, 778, 7778. Okay, this does have a pattern, but is it the same is it the Is it the same numbers repeating over and over? No. So I couldn't write this as 0.78 repeating, right? Because it's not 78 repeating, it's 778, 7778, okay, and so on. So I can't write that as a fraction and make the fraction equal to this exactly. This is the same thing. This is pi, 3.14159265359. It continues on and on. I can't write that as a fraction without leaving off numbers. I can't get this exact number because this number doesn't end, nor it doesn't have a pattern. So to write that whole number as a fraction is impossible. So we consider it irrational. Now I can round and say we just go with 3.14. I can write that as a fraction, yes. But if I wanted to get the whole number of pi, everything on there, could I write that as a fraction? No. So that's why it's considered irrational. All right, write this down. Another part of your homework today is going to ask you to classify all sets of numbers. It's going to ask you to identify as a whole number, a rational number, an integer, or irrational. So that's what we're going to do. Classify 1.31, 331, 331. Okay, Alan, what is it? Irrational. If you want to abbreviate, that's okay. That's fine with me. 45. Someone raise your hand and tell me what 45 belongs to. Camden.
Whole number?
It is a whole number. What else? Camden? Kurt?
Natural and rational.
Okay. It is a natural number. It's also a rational number. There's one other one. What is it? Tyler. It is an integer. -2 and 6/11. What is it? Ben. It's not an integer. Okay, it's got a decimal or it's got a fraction to it. Okay, integers don't have those, so it's not an integer. What is it, Alan? It's rational. I can write it as a fraction, so it's rational. 0. Miss Beck, what does 0 belong to?
Whole number.
It is a whole number. What else?
Me?
Yes.
Natural number.
It's not a natural number. No, naturals are 1, 2, 3, 4, 5.
Rational.
It is irrational. I can write it as a fraction. What else? Jaden. It's an integer. Good. Is there anything else? No. Right? That's it. Now, if you want to look in your book, I don't remember exactly what page it's on. It has a bubble that shows you all the rational numbers, and included in rational numbers is whole numbers. Included in whole numbers is like natural numbers. So you can kind of see it as it bubbles out, and then on the outside are irrational because it's not including any of those. All right. So if you need to use that diagram in your notes, that's fine. All right, here's your homework assignment.